All right, so in this lab, we'll be doing a simple solvent extraction. This is a very common organic chemistry technique. It's used for a variety of reasons. One important reason is extracting natural compounds or other compounds in general. It's also used to purify components or separate some components from a liquid mixture. And all these solvent extractions basically work on the principle of like dissolves like. We'll go with like dissolve slash mixes like. And so in order to do a solvent extraction, the first thing we need is two immiscible liquids. And remember that the word immiscible means that they won't mix. So they've got different chemical properties, different intermolecular forces. They are not like, and so they will not mix. The two that we'll be taking a look at today is water, which hopefully you know the structure and properties of water by now, and methylene chloride. It's a very common organic solvent. It has a bunch of other names. So methylene chloride is one of them. The other popular one is dichloromethane. Which also gets abbreviated as DCM. So you might hear me call it DCM in the video. It's just methylene chloride. And so this is a methane group with two of the hydrogens being substituted out by chlorines. So it looks like that. And then these two have different properties, so they will not mix with one another. And we can think about what property is going to determine which one's going to be the top or the bottom layer. If we took a look at the density of water, we'd see it's 0.997 grams per mil, while DCM's density is equal to 1.33 grams per mil. And so if we go ahead and mix them together, as we said, they won't mix and they'll form two layers. I'm going to put DCM down on the bottom, but think about the density. Think if that's actually what's going to happen. And then water on the top, right? So we'll get two immiscible layers. And so those are our solvents for our solvent extraction, but we actually want to extract some kind of solute. And so our solute here is going to be benzoic acid. So there's benzoic acid. And then the question is, when we dissolve benzoic acid in this mixture, is it going to go into the DCM layer or is it going to go in the water layer, right? And the answer to that is that it's going to go into both, right? But what's going to preferentially go into one versus the other. So if we think about which one it's going to go more in, this is something called the partition coefficient. And so it's an equilibrium, so it gets a K. And we're going to compare how much of it goes into the DCM versus how much goes into the water. And so this is going to be equal to the concentration of the benzoic acid in the DCM over the concentration of the benzoic acid in the water. Remember that these brackets mean concentration. And so this is what we're going to calculate is which layer is it going to go in. So think about the parts of benzoic acid that might make it go into one of these layers or the other. And so the steps for this lab are relatively simple. We're just going to take some benzoic acid and dissolve it in one of our mixtures, right, in our water DCM layers, mix them up real good. And then after that, we're going to extract one layer. Normally, this is done through what's called a separatory funnel. So there's a picture of a separatory funnel. And these come in all kinds of sizes from, small as maybe 1 or 2 mils up to, a whole liter. And so it's got this stopcock down on the bottom that allows the liquid to either go through or not go through. Your two immiscible liquids will not mix together. And then it's got this angled kind of down here. And so when this little line gets closer and closer to here, the separation will get smaller and smaller. And so it'll let you separate out the two liquids quite easily. We won't use this. We'll just use a conical vial and pipette out one of the solvents, but I just wanted to show you what's more commonly used. And so we're going to pipette out the DCM. We're going to evaporate the solvent off. We're just going to evaporate it under a flow of nitrogen gas. So basically, we're just going to pour some nitrogen gas on it and slowly evaporate it away. In real life, we would probably use, or in a real lab, we'd probably use a rotovap, which basically just evaporates the solvent off under reduced pressure. So you can Google rotovap and see what those look like. After we've evaporated the solvent off, we're going to let it dry for a bit, and then we're going to weigh out how much benzoic acid was in the layer that we evaporated off. And then from that data, we can find our K, our partition coefficient, assuming that we didn't lose any of the material. All right, so I've got my clean 5 milliliter conical vial right here with a screw cap attached. First thing I'm going to do is just add a piece of aluminum foil onto here just to protect it from any contaminants that the cap might have. We reuse these caps, so they might have some kind of gunk on there. So let's take some foil, cover up the lid, put the cap on, rip off some of this excess, and it'll go with the cap when I take it off. So got my 5 ml conical vial right here. To this I'm going to add 50 milligrams of benzoic acid, so I've got that right here, also in my secondary container right here. And so just go ahead and put a piece of whey paper in here. First I'm going to take the whey paper and fold it in half. Spread it out a little bit. Add it into here. And then go ahead and tear it. And then weigh out about 50 milligrams. It doesn't have to be exact, but it should be close. So I'm going to use proper weighing technique. I'm going to open both sides. And then I'll have my chemical in one hand and my micro spatula in the other, and pour some out until I get about 50 milligrams. Probably a bit much there. Let's take off a little tiny bit. Maybe remove just a tiny bit more. No, I took off too much. All right, and then you can see our mass right there, and we'll just go ahead and pour it into our conical vial. And now it's in our vial. All right, so we've got a conical vial with the benzoic acid in it. Next up, we're going to add some DCM, some methylene chloride to the solution. We're going to add 600 microliters. So press until the first press. Pick some liquid up. And then add it to your conical vial. And then we'll simply shift over and do the same with 600 microliters of water. Add it to our conical vial. And then put our cap back on. All right, so in our conical vial, you can see the two layers. The benzoic acid has actually all dissolved, but we'll still want to give this a good shake. So it gets all nice and murky, and then we're going to want to go ahead and open it just to vent it. Close it back up. Give it another good shake. And then go ahead and just let the two layers separate out. Cool. All right, so next up we're going to make our cotton filter pipette. So you can see I've got a long pipette here, and then I've got a little ball of cotton. And the key here is that you're just going to want a tiny, tiny piece of cotton. It's going to be barely visible. Right, so I'm just going to grab just this much amount of cotton, just a tiny amount. Go ahead and put it into the top of the pipette. And then you give a little tap to try to get it down. So we got it down there. And now what you want to do is use your copper wire to push this down. And so this part's going to be really the pain part for the slab. So just try to get it any way you can to go down. There we go. And then once you've got it kind of down in there, you don't want to force it too much. Just give it little taps and just continuously push it down. All right, so we have our mixture here, and then we are going to separate out the methylene chloride into this conical vial right here. And then in the background here, I've already pre-weighed out some 100 milligrams of anhydrous sodium sulfate, and so we'll just sprinkle that on top. So we've got our filter pasture pipette. Going to go ahead and open this up. And then we want to go ahead and just pick up just the bottom layer, and we want to try and do it in one go if we can. And so you want to pick this up fairly slowly. So squeeze the pipette when you're outside of the liquid. Squeeze the whole way. And then go ahead, insert into the liquid, into the bottom, and then start releasing. And you'll start picking up your methylene chloride. And you want to try to not pick up any water, and then just go ahead and transfer it over. You can see I made my filter pipette a little too tight, and that's why the liquid's taking quite a while to come out. But it's actually a pretty good thing because when I picked it up, it made it go a little slower, which was more controlled. So overall, not bad. Cool. So we've got all of our DCM in here. And now we can go ahead and just sprinkle in our sodium sulfate. Give it a little swirl. And then we can wait for this to dry. All right, so we've got our methylene chloride right here with our sodium sulfate in there. You can see it should be all dried up. It's been over 10 minutes now. And we're going to go ahead and transfer it over in this pre-tared vial that has a boiling chip inside of it. So we'll go ahead and take our filter pipette and just try to suck up the liquid and not try to pick up any of the sodium sulfate. Transfer it over. And then we're going to add another 600 microliters of methylene chloride to wash this off. You can see that the DCM, the methylene chloride, dries quite quickly. So you can see we've got some benzoic acid in our pipette. Hopefully we can wash that off in this next step. Add another 600 microliters of methylene chloride. Just to rinse off our sodium sulfate. And then go ahead, suck it up and transfer it over. Cool. And we've got it all, so now we can go ahead and try to evaporate off our methylene chloride. All right, so we've got our warm sand bath. It's reading about maybe like 47 degrees Celsius. We'll go ahead and put our pre-tared conical vial into our warm sand bath, dig it in there a little bit, surround it with a little bit of sand. And then these little rubber tubing hoses with a pipette on the end are connected to the nitrogen gas. You can see that it's clamped shut, so we can just pull this up here and that'll open it, and then you can feel a gentle stream of nitrogen gas pouring through here. And so you just want to go ahead and try to get this stream over the liquid. Don't shoot directly at the liquid, just shoot at the sidewall next to the liquid. You can see some of the white solids starting to build up.
Oh no, I wasn't on it when I wrote it down. Oh, okay. It was like that. I knew there was some that's like quite because I broke the clump. Now it's here, so I'm gonna weigh it and then it stays on the same. So you said 1,000 plays, right?
On the very last one, yeah.
So if it's around 90 something, I'm just gonna do that.
Wait, isn't it 10?
Well, this is with nothing. I knew this was like that. It's clump, so that's why. Yeah.
All right, so we'll call this dry enough for the first run. We'll go ahead and take this out. You can see all that remains is this kind of white solid in here, which is our material. And so we'll go ahead and weigh this and then break it up a little bit and then reweigh it. All right, so you can see we have our white solid here. We'll take our micro spatula and just break up this solid. Push it generally towards the bottom. And then we'll put it back under the nitrogen stream and then reweigh it and repeat this process until our weight is no longer changing, which is indicating that our compound is nice and dry.